Gears are mechanical components used to transmit power and motion through the successive engagement of their peripheral teeth. Gears perform certain key functions within machines and assemblies, such as reversing the direction of rotation or altering the angular orientation of rotary motion. Gears are also used to convert rotary motion into linear motion and vice versa, or to alter gear speed ratios. The methods of machining gears can be classified into two primary categories: gear generating and gear form cutting. Many of the processes used to machine gears may also be used to finish gears. Gear generating involves gear cutting through the relative motion between a rotating cutting tool and the generating motion or rotation of the workpiece. The primary gear generating processes include hobbing and shaping. In hobbing, gear teeth are progressively generated by a series of cuts using a helically fluted cutting tool called a hob. Both the hob and the gear blank rotate as the hob is fed axially across the face of the blank. Hobbing is the principal method for producing spur gears and helical gears, and is also used to produce many special gear forms. The main limitation of hobbing is that it can only be used to produce external gears. Hobbing can be performed on a single gear blank, but also allows for the stacking of workpieces to increase production rates. Shaping generates gear teeth by rotating the workpiece in contact with a reciprocating cutter. The reciprocating cutter may be a pinion-shaped cutter, a multi-tooth rack-shaped cutter, or a single-point cutter. The pinion-shaped cutter's axis is parallel to the gear blank and begins cutting by reciprocating while feeding gradually into the blank to a predetermined cutting depth. The cutter and gear blank rotate slowly at the same pitch circle velocity as the cutter enters and exits the cut, incrementally generating the gear teeth. Rack-shaped cutters typically have between 6 to 12 teeth that reciprocate into the gear blank. Once the rack cutter finishes a pass, the cutter is disengaged and returns to a starting point to begin cutting again. When shaping with a single-point cutter, the cutter reciprocates, making successively deeper cuts until a predetermined depth is reached. Gear shapers are used to make internal gears, shoulder gears, and many other gear types that cannot be produced with hobbers. Shapers can also produce non-involute shapes, such as a cam and gear on the same shaft. Gear form cutting typically involves the use of formed tooth cutters that have the desired gear shape or profile. The primary gear form cutting processes include broaching and milling. Broaching is the fastest method of machining gears and is performed on many different machine types using a multi-tooth cutting tool called a broach. The broach or the gear blank are pushed or pulled relative to each other to remove material. Each tooth on the broach is generally higher than the preceding tooth. As a result, the depth of cut increases with each tooth as the broaching operation progresses. The conventional method of broaching is used mainly to produce internal gears. For external gears, pot broaching is used. Pot broaching is performed on special machine tools having a hollow broaching tool assembly called the pot. Gear blanks are either pushed down, pushed up, or pulled up through the pot to generate the gear teeth. Milling is a machining process that uses the relative motion between a rotating, multi-edge cutter and the workpiece to generate gear shapes. Milled gears are typically produced using cutters that mill each gear tooth space individually. To produce large, coarse pitch internal or external spur, bevel, or helical gears, a process called gashing can be used on heavy-duty milling machines. Gashing involves plunging the rotating cutter into a blank for rapid metal removal. After machining, gears may require heat treatment to meet hardness requirements. After heat treating, gears usually require finishing to nullify any distortion that may occur. In some cases, gears are machined and finished before heat treatment, and then once processed, surface finished to remove distortion from the heat treatment.